Okay, welcome back to another video on the Maths channel. It's your teacher, Mr. Lim here. In this video, we're going to be looking at accuracy of measuring instruments. So by the end of this lesson, you'll be able to explain why measurements are approximate and find the limits of accuracy. So what we need to know is that actually, in reality, all measurements are approximate. Which means that everything we measure is never completely accurate. Okay, so whether we use a ruler or scales, a clinometer, anything that we use is never completely accurate. A thermometer, things like that. Now, there are a variety of reasons for this, and it can include the fact that there could be errors with the instrument or equipment where they are not completely accurate. Or maybe the person read the equipment at a wrong angle, resulting in an inaccurate reading. Okay, so accuracy is the measure of how true the measure is to the real one. And I put real in quotations because there's no such thing as an exact measure. Whereas precision is the ability to obtain the same result over and over again. So why are measurements approximate? It's because mainly the instruments that we use aren't completely accurate. All right, we don't know for certain what an exact measurement is, and so in reality, whatever we've measured is actually somewhere between a lower number and a higher number. It could be, let's say we measured something and it was 30 centimeters. It could be 30 centimeters, but in reality, it's probably somewhere between 29.5 and 30.5 centimeters. So let's have a look at finding the limits of accuracy, which is pretty much what I just said. Right, so the limits of accuracy tell you what the upper and lower boundaries are for the measured value. So what two numbers does the measurement that we recorded actually lie between? All right, so the limits of accuracy are given by these two formulas. Now, I prefer it if you didn't actually memorize these formulas. I prefer you to know what to do. Okay, so we've got upper limit is equal to measurement plus half times the smallest unit of measurement. Lower limit is equal to the measurement minus half times the smallest unit of measurement. So the question is, what is the smallest unit of measurement? Okay, and we'll have a look at this. Now, here we've got an example. When measuring to the nearest centimeter, 86 centimeters has limits from 85.5 up to 86.5. So let's say we've got a line. Okay, let's say we've got a straight line. We took our ruler and we said, okay, according to our ruler, it says it's 86 centimeters. Okay, we say that's 0, and that's 86. We said that it's 86 centimeters. But in reality, is it actually 86? In reality, it's somewhere between 85.5 to 86.5. Okay, we don't know where it is, but it's somewhere between there. So this here, that's our lower limit or lower boundary, and that 86.5 is our upper. All right. Now you can see here, according to the formulas, it says measurement plus or minus half times the smallest unit of measurement. Now let's say our ruler only does the nearest centimeter. Okay, the nearest centimeter, which means if we measured 86 centimeters, the smallest unit of measurement, we look at the last digit and it becomes a 1. The smallest unit of measurement is 1 centimeter. So half of 1 centimeter is 0.5 centimeters. So we take our measurement and we add the half a centimeter. That's how we got 86.5. Or we take our measurement and we minus half the centimeter. That's how we got 85.5. So that's if our ruler was only in centimeters and it didn't give us any millimeters at all. But let's say, for example, here we've got the same line, but we used a different ruler. And this time the ruler rounds to the nearest millimeter, right? So we're measuring to the nearest millimeter. The limits of accuracy for 86.0 centimeters are, okay, so let's say we've got the same line, but this time our ruler tells us that it's actually 86.0 centimeters. So this time our smallest unit of measurement, we're looking at that. Always look at the last digit. So the smallest unit of measurement, we're basically making everything else equal to 0. So this 86 becomes 0. And the last digit becomes a 1. So we want half of this, right? Half of 0.1 is 0.05. So we're going to take our measurement of 86.0. So here it should say 86.0. I should probably write this in, by the way, is 0.1 centimeters. Okay, that's the smallest unit. This becomes 0, that becomes 1. So we get 86.0 plus half times 0.1. Okay, that's our smallest unit of measurement. Half times the smallest unit of measurement, which is 86.05. And we've also got 86.0 minus that, 85.95. Okay, so that's how we got these two values. Now, in my opinion, it's actually easier to not use the formula. Right, so this is what I like to do. I always like to work out the upper bound first, and then I can work out the lower bound, and therefore the limits of accuracy is just between those two numbers. But for the sake of this lesson, let's also just work out what the smallest unit is for each of these examples. So in example A, we've got 72 centimeters. That becomes a 0, but that becomes a 1. So the smallest unit is 1 centimeter. Alright. Now the upper bound is this 72 plus half of the 1. So we could do this, 72 plus half of the 1, 72.5. And the lower bound, we could do 72 minus half of the 1. 71.5. Right? And therefore the limits of accuracy is between this and this. 71.5 centimeters to 72.5 centimeters. Right? So we've measured some length. It says it's 72 centimeters, but in reality, it's somewhere between 71.5 and 72.5. Okay? Now here we've got one of these thermometers, right? During COVID, we had to use a whole bunch of these. It says 36.9 degrees. So the smallest unit is actually 0.1 degrees, right? Because we've got 36.9. This becomes 0. The last digit becomes 1. So 0.1. So the upper bound is the measurement plus half of the smallest unit, 0.1, which is 36.95. The lower bound is the measurement minus half of the smallest unit, 36.85. Right, so we've got 36.85 to 36.95. So this thermometer rounds to the nearest tenth, right? Rounds to the nearest tenth. It says that someone's temperature is 36.9 degrees. It could be that, but in reality is actually somewhere between 36.85 and 36.95. Now, if we have a look at these two examples, A and B, we should be able to hopefully find a shortcut that enables you to find the limits of accuracy of the lower bound and the upper bound really easily. And my trick is to always to start with the upper bound by adding a 5 to it. So if we see the 72, right? I'm going to add the 5 to it, 0.5, 72.5. This 36.9, it will become 36.95. So this 52.8 is just going to become 52.85. grams. Okay? Now, that's 52.85. If we have a look at the lower bound now, I'm comparing the lower bound with the upper bound. I can see that the only difference is the second last digit. The 2 became a 1. The second last digit, the 9 became an 8. The second last digit, the 8 will become a 7. So this one here will be 52.75 grams. So we can see that the limit of accuracy is actually 52.75 to 52.85. Now, of course, we can double check, right? Smallest unit will be 0.1 grams, right? That becomes 0, that becomes 1, so 0.1. And so if you want to, you can take the measurement, add half of the smallest unit, 52.85, that's my upper bound, or we can subtract 52.75. But I prefer to do this without even working out the smallest unit. But let's just do it so that you can get used to it. Now let's have a look at question D and E. This is a pretty common exam question here. So we've got a shape, a rectangle that's 9 by 4 centimeters. So we can see here that the smallest unit is actually 1 because it's the last digit. Smallest unit of measurement is 1 centimeter. Now, I want us to work out the lower bound and the upper bound of the perimeter and of the area. Now, in order for us to do this, we actually need to work out the lower bound and upper bound of each side. So if we have a look at the 9 centimeters, all right, so the length, the width, and therefore the perimeter. Okay, length, width, and perimeter. Okay, so let's have a look at this. The length is 9 centimeters. So because the smallest unit of measurement is 1 centimeter, the upper bound of the length is 9 plus half times the smallest unit, 9.5. In reality, it could be up to 9.5 centimeters. Now, if you want to use my trick, you can say, oh, the second last digit, minus 1, this will be 8.5. Or if you want to, of course, you can just 9 minus half times the smallest unit, 8.5. What about the width? The width here is 4 centimeters. So we could use my trick, add a 5, so 4.5, minus 1 from the second last digit, that becomes 3.5. And now we can use these values to work out the perimeter. So the perimeter of this shape, in case our ruler was completely quite inaccurate. Let's say it measured it to be 9, but in reality it's actually 8.5. And this 4, it said it's 4, but actually it's 3.5. If these were the real measurements, then what's the actual perimeter? Well, the perimeter would be the 8.5 plus 3.5 times 2. 24 centimeters. Or let's say our ruler was wrong because it was too small. It says it's 9, but actually it's 9.5. It says it's 4, but actually it's 4.5. Then our perimeter would be 28. So what does this mean? It means that even though we are to look at this and we think, perimeter 26 centimeters, we can say that perimeter of this rectangle is 26 centimeters. In reality, it's actually somewhere between 24 and 28. It could be 26, right? But it's somewhere between these two. So 24 centimeters to 28 centimeters. That's the lower bound, that's the upper bound. So let's have a look at E, all right? Again, it's the same thing. Okay, but this time we're going to be looking at area. So we can see that the smallest unit of measurement is 1 centimeter. Length, width, area. So again, the length and the width is going to be the same thing as up here, right? The upper bound of the 9 centimeters is 9.5, and the lower bound is 8.5. The upper bound of the width is 4.5, and the lower bound is 3.5. And so, if the actual length of the rectangle is 8.5 and the actual width of the rectangle is 3.5, then the area would be 8.5 times 3.5, because length times width is the area of a rectangle, 29.75 centimeters squared. It's the smallest area. It actually is, we believe. Or the largest would be 9.5 times 4.5, 42.75. So, we can see here, even though when we look at this question and we say, the area of the rectangle is 36 centimeters squared, in reality, it's somewhere between 29.75 and 42.75. Alright, so please do not do this. Do not say it's 36 and therefore the upper bound is 36.5 and the lower bound is 35.5. It doesn't work like that. We need to work out the upper bound and lower bound of each side length and then use those values to work out the upper and lower bound of the area or perimeter. Alright, so that's it for this video. I hope you found this video helpful. So let's just recap what we looked at. We were able to explain why measurements are approximate, right? And we were able to find the limits of accuracy, which is somewhere between a lower bound and an upper bound. You don't really need to memorize these formulas, just know what to do. My shortcut was add a 5 to the measurement to get the upper bound. Look at the second last digit, minus 1 from that to make the lower bound. Okay? So, if you have any questions, please comment down below. If you found this video helpful, please give it a like. And if you would like more content, then please subscribe to my channel. Have a good one, and I'll see you in the next video. See ya.